Okay, so instead of recording it with a class like I did first period, that shut down on me. So we're gonna try this video. Hopefully it works. If not, we'll see what else happens. Okay, so the matching part, those are the answers to it. L, M, D, C, E, K, H, J, I, B, A. Go ahead and pause the video if you want to. But that's just the real basics of it, just to let you know. Form. You are responsible for knowing which gas laws go to what and what they deal with. So like Boyle's law would be pressure and volume, Charles would be volume and temperature, Gay-Lussac's would be pressure and temperature. So that kind of stuff is what you're going to be responsible for. Okay, so the next part is this guy. 14. According to kinetic molecular theory, gases have 5 characteristics. List and describe them. So there's 2 of them that I want you to do. They have no volume, they have elastic collisions, constant random straight line motion, don't attract or repel each other, have an average kinetic energy directly related to Kelvin temperature. Okay. They also do this fun thing. They expand to fill any container, because that random straight line motion. They're like fluids, so they have no attraction. They have very low densities, so there's no volume. They undergo effusion and diffusion, and they can be compressed. Again, pause it if you want to get more. Next question. Let's see. Alright, so the next question is, at what conditions do ideal gases exist? The answer to that is going to be at low pressures, high temp, and in nonpolar atoms or molecules, because there's nothing there that attracts each other in the nonpolar atoms or molecules. So again, pause it if you need more. 16. What are conditions for STP? Very simple. 0 degrees Celsius, 1 atm, or 273 K, 101.325 kilopascals. Either one of those would work. So now, let's do this. What's the formula for ideal gas law? We got P, which is pressure. You got V, which is volume. N is your moles. R is universal gas constant or ideal gas constant. Either one works. And then T is going to be your temp. And your formula is going to be PV equals nRT. Alright, so the universal gas constant is 0.0821 liters atm K mole. Okay. Now, for the problems, I only wanted to do 3 of them. Okay. Mainly because they repeat over time, and you should be able to figure out how to do them. That's the hope, at least. Alright, we have this one. Oh, yeah, 19, 20, 21. Just go ahead and skip those. It goes into stuff that we've already done before, or stuff that we used to do, but we don't anymore for X, Y, and Z reason. Alright, so to what volume would you have to change 20.455 liters of gas at 162.6 kPa? So what we got going on here, V1 equals 20.455 liters. My P1 equals 162.6 kPa. V2 equals question mark. P2 equals 12.5 kPa. So we're going to be using Boyle's law. Now the way that we know that, if you don't know how to do this, then pay attention. Basically what I do is I start with my combined gas law, which is that, and then what I end up doing, I'm not given temperature at all. Assume no temperature change. So I just go ahead and I erase my temp, like that. And so now I have Boyle's law. So I'm going to plug it in. 20.455 liters times 162.2, sorry, 0.6 equals V2 times 12.5. So I divide both sides by 12.5. My V2 is going to equal 266 liters, if I remember correctly. So 266 liters. Now, notice a couple things. Thing number one, you get this guy right here. That's your data set. You need to include that for 2 points. Okay. You need to include this part right here for 2 points, which is your work. If you don't include this, I give you credit for that only. Okay. You must include your work. Plus 2 points for your formula, 2 points for the right answer, 1 point for the right sig figs, and 1 point for the right units. Okay, you must put those. It's not an option. Alright, so let's look at 23. Alright, to what volume would you change? Oh, no, wait, never mind. I don't want to look at 23, that's right. Because that's the same one. So then in that case, so it's volume and no, wait. I thought, oh, sorry. Right, so we have volume and temperature. Never mind. So I have volume and temp, volume and temp. So I'm going to use Charles' law. So, it's 48.1 liters. Temperature is 304.4 degrees C plus 273 equals 577.4. V2 is what we're looking for. T2 is 201.0 degrees C plus 273 equals 474. Okay. So then it's V1 over T1 equals V2 over T2. And then I plug it in. So it's 48.1 liters divided by 577.4 equals V2 over 474K. So however you do it, I would do it where I'd multiply these two numbers together and then divide by that one. Basically it's the cross multiply and divide, but I don't have to cross multiply this side. What I end up getting is my V2 equals 39.5 L. So I end up getting 39.5 L. So again, 2 points for the data, 2 points for the formula, 2 points for the work, 2 points for the right answer, 1 point for the sig figs, 1 point for the unit. Right, so the last one I wanted to do was number 27. Pretty much all the other ones are self-explanatory, you know what to do. So, with 27, what we got is we see moles. So if we see moles, the very first thing we got to think of is PV equals nRT. So the reason why this one's a little bit different, A, it involves moles, B, it's not about changes. It's just describing the actual physical state of the thing. So what pressure is exerted in the atmosphere? So we're looking for pressure in ATM by 1.91 mole of gas, 12.8 liters container at 4.46 degrees C, which you add 273 to that, and that gives you 277.46K. Now our R, we already know that, it's 0.0821 liters ATM K mole. So our formula is PV equals nRT. I plug it in. 12.8 liters equals 1.91 moles times 0.0821 times 277.46. And apologize about that part. Okay, so I multiply all that together. I get P equals P times 12.8 equals 43.54. 51, excuse me. So all these guys multiply together, divide both sides by 12.8, both sides by 12.8. So P ends up being 3.4 ATM. Okay? So, right number sig figs, right number, right units. There you go. That's what I'm expecting of you to do tomorrow. There will be some biology on the test, so good luck with it. I wish you the best. I'll be here today after school and tomorrow before school.